So today, we're going to crack open the scientist's toolkit. We're looking at the essential gear that turns a wild guess into a solid, undeniable fact. Because in the world of science, getting things close enough just doesn't cut it. Getting it just right, well, that's everything.
So let me ask you something right off the bat. In science, why is a guess never good enough? Why can't a chemist just, eyeball an ingredient for a new medicine? Or why can't a physicist just sort of calculate a rocket's trajectory?
Well, the answer really gets to the heart of it all. It's because science is built on a foundation of accuracy. Every single discovery, from the tiny processors in your phone to the massive alloys in a jet engine, all of it relies on measurements that are repeatable, reliable, and incredibly precise. That is the bedrock of fact.
So how do scientists get to that level of accuracy? Well, it's all about having the right tools for the right job. We're going to take a little tour of the 3 most fundamental tools you'll find in any lab, starting with the one that measures something we can all feel: temperature.
And for that job, you need the thermometer. Now, its purpose seems pretty simple, right? It tells us exactly how hot or cold something is. But that one simple reading is the gatekeeper for so many complex processes, from making sure a vaccine stays stable to controlling a nuclear reaction.
Now, here's what's really interesting. The technique matters a lot. To get a truly accurate reading, you have to look at the scale directly at eye level. If you look from above or below, you get something called a parallax error, which is basically a trick of the eye that gives you the wrong number. Now, a single degree might not matter for the weather forecast, but in a lab, that could be the difference between a major breakthrough and a complete failure.
All right, let's keep going. From hot and cold, we're going to shift to how much stuff is actually in an object. We're talking about measuring mass.
And the instrument for this is the balance. Now, it is so important to remember it measures mass, the actual amount of matter in something. That's totally different from weight, which is just how much gravity is pulling on that mass. An object's mass stays the same, whether it's on Earth, the Moon, or Mars. And that's exactly why it's so fundamental in science. So the number 1 most crucial rule when using a balance: you have to start from the right place. Before you weigh a single thing, you must zero it out or tare it. It's like making sure you start a race at the actual starting line. Think about it. In medicine, the active ingredient in a pill might only be a few milligrams. Forgetting to zero the balance could make that medicine useless, or even worse, dangerous. It's a tiny step with huge consequences.
Okay, our final tool for today is all about liquids. How do we know exactly how much space a liquid is taking up? For that, we need a way to precisely measure its volume. And for that, we have the graduated cylinder. And I want you to pay close attention to that key word in its definition: accurately. See, this piece of glassware isn't just for holding liquids. It is specifically engineered for one single thing: getting a precise liquid measurement.
Now, using one of these correctly is a bit of an art. Because of how water clings to glass, the surface forms this little curve called a meniscus. The golden rule of the lab: you always read the volume from the very bottom of that curve. It's a tiny detail, for sure, but it's the detail that ensures a chemical reaction gets the exact ratio of ingredients it needs to work.
And this slide right here perfectly illustrates why scientists are so picky about their tools. You'll see beakers all over a lab, but they're for a totally different job. A graduated cylinder is tall and narrow with lots of precise little markings. It's built for accuracy. A beaker is wide with only a few rough markings. It's just for holding, stirring, or heating things up. Trying to measure precisely with a beaker is like trying to do surgery with a butter knife. It's just not the right tool. For accuracy, the graduated cylinder wins every single time.
All right, you've seen the tools, you've learned the techniques. I think it's time for a quick check to see what you've picked up. Ready? Let's do this. First question's up. Which tool would you use to measure the mass of a rock? Come on, think back. Which one measures the amount of stuff inside an object?
If you said the balance, you are absolutely right. That's exactly what it's for. Nice work.
Okay, next one. Which tool is going to give you a more accurate measurement of a liquid's volume? Is it that all-purpose beaker, or is it something else that's designed specifically for the job?
Yes, it's the graduated cylinder. Remember, it is all about the design. Those fine little markings and that tall, narrow shape are there for one reason and one reason only: precision.
So let's kind of bring this all together with this one idea. The goal of a scientist is to get the right answer. The job of a scientific tool is to make that possible. These instruments, the thermometer, the balance, the graduated cylinder, they aren't just pieces of lab equipment. They are the essential bridge between asking a question and getting a reliable, factual answer.
And that brings us to our final thought for today. As you go about your day, I want you to think about this. What's one thing in your life that just wouldn't be possible without someone, somewhere, making an accurate measurement? From the recipe for your morning coffee to the code that's running your phone, I bet you'll start to see precision hiding everywhere. Thanks for joining me.